So we just finished the model building of SVM, and it took around 2 minutes to build this whole SVM model. It depends on the system to system. If you have a little powerful system, SVM will not take, it will take even lesser time. Now let us see the accuracy of the model. Let us see the summary of the SVM that we have built. There are 10 number of classes, yes, these are the levels, and there are 2000 support vectors, and the kernel is radial. Since we did not mention anything, kernel will be taken as radial basis kernel RBF. Now let's try to see the confusion matrix and then see whether what is the overall accuracy of this model. So these are the predicted labels and then the confusion matrix. Here is the confusion matrix. Yep. We need to have the column name, that is the actual name, predicted versus actual. So this is the confusion matrix, and the overall accuracy is 99%. Yes, it's training data, so it looks like fairly accurate model, but what matters is on the testing data, how is it performing. So on the out of time validation data, what is the accuracy? So on the out of time validation data, the confusion matrix reveals that it is 93% accurate. In fact, that's not a bad model at all. So let us see predicted versus actual values. So let's build the model on the full data. This is the model on the full data, and then we are rebuilding the model once again. So let us see some of the predictions and what was the actual label, whether the label is correct or wrong. So here are some of the predictions. So label is 9, prediction is 9, label is 6, prediction is 6. These are some of the right predictions that we have made out of the, with the test data. The confusion matrix shows that it is 93% accurate and 7% inaccurate. So out of this 93% SVM, we can see some of the examples where actual value is there and predicted value is also predicted as accurately. And then let us see some of the wrong example. Looks like sometimes 6 might be predicted as 1, 7 might be predicted as 1, 3 might be predicted as 9 or something like that. So let us see some of the wrong examples where SVM was not able to find out or classify the actual correct class. Label is 6, prediction is 5 for this one. Label is 0, prediction is 8. Label is 2, prediction is, actually it is 2, prediction predicted as 0. Label is, so there are 7% of such cases where SVM predicted wrongly. So that is the overall SVM introduction. So in this one we just got an idea about SVM, how to build SVM, what is SVM, how do we validate SVM results, what is a kernel trick, etc. There are many softwares that are available for SVM implementation. In fact, some softwares are exclusively for SVM, and SVMs are really good for text classification and image classification. So kernel trick is the one that makes SVM slightly powerful. By default or by model, SVMs are linearly separable models, linear separator. So choosing the appropriate kernel is the major trick in this whole process of SVM model building. And for large data sets, SVM, in fact, like in any other machine learning algorithm, it takes a lot of time.